So this video has been chapterized so you can find what you want quickly. The first thing we look at in this video is the difference between speed and velocity and how we calculate velocity or speed. We'll then look at what acceleration is and how we calculate it. We'll then look at how an object can be travelling at constant speed but still be accelerating, a special case of circular motion. We'll then do some practice questions on acceleration where you can pause the video and I'll go through the answers afterwards. So let's start off with the difference between speed and velocity. Remember, speed is a scalar quantity. It's simply how fast you're travelling. So a car could be travelling at 20 metres a second. It's just the magnitude. But of course a vector quantity is both speed in a direction, and that is velocity. So the car at the top might be travelling at 20 metres a second, but we can say it's travelling at plus 20 metres a second if it's travelling to the right. If it's coming back the other way, then we say it's travelling at minus 20 metres a second. The negative means it's travelling and tells us it's travelling the opposite direction, still at the same speed, but in the opposite direction. So in your equation sheet, which you have to learn, except for the exam in 2022, distance travelled is speed times time, and they use S for distance travelled, so be careful. V stands for velocity, which is the same in magnitude as speed, and T stands for time. So let's quickly check this one. If a car is going round a roundabout, is this car travelling at constant speed? The answer is yes, the magnitude is staying the same, but it's not carrying on at a constant velocity because the direction is constantly changing, and therefore its velocity is changing because it's a vector quantity. So what's acceleration? Well, acceleration is the change in speed every second. Some people find this quite odd to get used to, so I'm going to give you an example. So if a car accelerates at 4 meters per second every second, that means every second its speed changes by 4 meters per second. And sometimes you see the units as meters per second squared because it's meters per second. So let's just look at this. So if it starts stationary, after 1 second its speed would have changed by 4, then it'll go up to 8, then up to 12, then up to 16. Supposing it then travels at a constant speed for the next 3 seconds, and then finally, if the car accelerates at minus 2 meters per second every second, that means that it's losing 2 meters a second of speed every second. We'll take it away. So that will go down to 14, 12, 10, and 8. So that gives you a better idea of what's actually happening when things accelerate and decelerate. So if we want to work out the acceleration in the first 4 seconds, then acceleration is change in velocity over time. So the change in velocity over the first 4 seconds was 16 meters per second. The time taken was 4, and so that gives us 4 meters per second every second, which is also equal to 4 meters per second squared. And the same for decelerating. The change in velocity will be 16 minus 8, which is 8 meters per second, divided by the time, which was 4 seconds, gives us 2 meters per second every second. And we can call that deceleration, but if we have to quote the acceleration, we'd put a minus sign in front of it. So acceleration is the change in velocity over time taken. And in terms of magnitude, if you're given the change in speed, you would use that. And the delta sign there means changing. And so we can put it into a triangle here, which allows us to work out the change in speed will equal acceleration times time. And of course, time would equal the change in velocity over divided by acceleration. So in terms of circular motion, sometimes you're asked, if the speed is constant, why is the object accelerating? Well, it's a special case when, of course, a car goes in circular motion. And of course, although the speed is staying the same, the velocity is changing. Because velocity is a vector quantity, its direction is changing, and therefore it's accelerating. So this is what you'd say. Although the car is travelling at constant speed, its velocity is changing. This is because it's changing direction and the velocity is a vector quantity. And finally, so the car is accelerating, as acceleration is the rate of change in velocity. So rate means the change per second. So if you now have a go at filling out this first bit of the note sheet with me, and then I'm going to ask you to pause the video and have a go at these questions yourself, and I'll go through them in a minute or two with you. So firstly, velocity is a vector quantity. It has magnitude and also direction, which means that car is travelling at minus 20 meters a second. So acceleration is the rate of change of velocity. That's how much the velocity changes every second. So acceleration, which is measured in meters per second squared, is equal to the change in velocity in meters per second divided by the time taken in seconds. We can write this as A equals delta V over T, where the delta sign means change in. Just before you pause the video, let me help you out with answering the table at the end. You've been given the starting speed and the final speed. So what you can do is you can work out the change in speed. Of course, for the first one, it will be 6 minus 2, so change in speed will be 4. The second one, the change in speed is 20. And of course, later on, you're given the acceleration and the time. So remember, change in speed is acceleration times time, which will be 10 times 2, which is going to be 20. And that will help you work out the final speed because of the change in speed. So pause the video and have a go at this exercise and then check with your answers in a minute.